Hey everyone, welcome to Cloud Robotics Working Group. Today is just a general catch up, anything on people's minds, essentially. We have a new participant today, Rick. Rick, would you like to introduce yourself for the group?
Hello, my name is Rick Hernandez. I'm a robotics engineer, and I've been doing robotics engineering for probably about 10 years or so. I do primarily a lot of software development. I do have mechanical design, electrical background as well, but I'd love to see what I can do to participate and kind of help assist this group in achieving its objectives. And it's really fascinating what you guys are trying to do. So I'd really want to see what I could do to participate and help.
Great, thank you.
Good. I think you've been here before at least once, right? Your name looks familiar.
Oh yes, yeah. No, I've been here a couple times.
Yeah. So where are you? Where are you at right now?
I live in Irvine. I'm actually currently at a client site in Chicago, but I live in Irvine, California.
I mean, like, what sort of robotics do you do?
Oh, I do consulting, and so I'll go and advise. So right now, I'm essentially working for my own business, and so I'll go and other companies hire me. They'll ask for either software projects or engineering of some kind, or even a market study, and then I'll go and assist them in those projects.
Sounds good. Cool. Which part of the stack are you most comfortable with?
In terms of, I think the past couple of years have primarily focused on software.
Yeah, but which part? I mean, robotic software starts at firmware, goes through low-level driver control, and then ROS and navigation, SLAM, localization, cloud, web, video. It's a big stack.
Right now, it's primarily ROS.
Okay, cool.
Very cool. Good to have you. We tend not to introduce ourselves to new people. I wonder if we should have a very short introduction to new members, well, unless it's busy and we don't have time. But I think we've not done it in a while at least. So I'll go first. I'm Michael. I was at AWS until a few months ago. Now I'm also freelance and I make videos and blog posts on connecting robots to the cloud. Essentially, I think it's progressing slowly and I want to help it however I can, which is also my motivation for bringing this group together. So as well as on my own channel and here, I just want things to be easier for people. How about either of you?
Chris, you can go ahead.
Sure. Yeah, so I'm Christian Fritz. I used to be the head of software at a robotics company called CRWG. I like to mention that because that's where I got sort of my first foray into startups and robotics, and I learned a lot about the needs for software and robotics, and it's sort of what logically led to what I'm doing now, which is I've been working on transitive robotics for the last 4 years. It's a startup where we develop robot fleet management components. So unlike Formant or In-Orbit or other like third-party fleet management systems, we just make components that our customers use to embed in their own fleet management systems, so that's how we've been growing. And the main focus is still on WebRTC-based tools for like video streaming, remote teleoperation, remote access kind of things.
All right, my turn. Giovanni Toffetti. I'm a docent, which means a senior lecturer at the Zurich University of Applied Sciences. And I come from a cloud computing group, which started working in robotics with a European project that was called Fiverr, that was connecting ROS with the cloud. And then we did a Swiss project with Raputa Robotics, which some of you might know. It's a spin-off of ETH. And we built with them the first prototype of a platform as a service for robotics of what then became their platform, Raputa.io. And since then, so that was like 2018, I think, more or less. So since then, we've been working with ROS, distributed ROS most of the time. I teach robotic application programming, which uses ROS most of the time. And we have a a setup that is a cloud robotics setup. So we use a Kubernetes cluster for running ROS instances on the Kubernetes cluster. And then we have physical robots that are connected to the cluster so that the students basically have the entire end-to-end environment which is connected. And they can first develop things in simulation and then simply say, okay, now I want to connect, my daughter is screaming, I want to connect the robot to my code, and then it makes it look like sim to real is very easy. But of course, we all know it's not.
Well, thank you. I really appreciate everyone's introduction. Thank you very much.
Giovanni, are you keeping in touch with the Raputa folks?
Not so much anymore. I mean, I wrote to Gajan a few. I think my last exchange with him was 1 year ago, more or less. He came to a European. He gave a presentation at the European Robotics Forum where we had the Cloud Robotics workshop. He was one of the keynote speakers, but I haven't spoken to them. I know they're in the US now. They opened up shop there, and they're doing mostly logistics actually, rather than cloud robotics anymore. I'm always a bit.
That's what I was trying to understand. It sounded like it came out of that Robo Earth project, right? And then
indeed,
and it was meant to be a platform, and I really like the going in hypothesis. But it seems like they now have their own hardware for warehouse, and it's also mostly a Japanese project now. Is that right?
It became a Japanese project quite early, actually. The CEO Gajan studied in Japan before doing his postdoc, I think, at ETH. And so once he opened up the company, it was already a dual a company that had 2 feet, one in Switzerland and one in Japan. Sorry, guys, some screaming girl.
No problem.
Sorry about it. This is dinner time, and they're going crazy there in the kitchen. Yeah, and that was it. And then they got acquired by SoftBank, and I think they closed shop in Switzerland and opened in Japan only, and now they're Japan and US.
I didn't realize they were part of SoftBank. Good to know.
Yeah, I think they got acquired quite early on, and then they had some additional runs of funding. But now they mostly do logistics with their own platform. But the cloud robotics thing was somehow, I think they are somehow leaving it where it was. They're focusing much more on logistics now than anything else.
Yeah, that's a little bit of the sad truth about a lot of robotics companies. Once they get too much money, they realize the only market that can justify this big of a valuation is warehouses. And I think that's also why the Digit, Agility's humanoid robot is working in warehouses, which sort of obviously is not the place where you need like the benefits of a humanoid, right? But well, can't have it both ways. A huge market and something that requires all of the cool things that you build. But although Raputa, I feel like if they had been, maybe they were a little too early, right? Because they were an open source fleet management system from what I recall.
Exactly, they were really too early, because now I see people on Twitter getting excited about. There's another company there in California that is now doing Docker for robots, basically, and I see people
Miro
getting excited.
Miro ML?
I think it is that one indeed. I think people are getting excited about it, but I mean, that was Raputa's thing in 2018. So I don't know what's the difference is now. Honestly, I haven't investigated them, but it seems the same thing. Build images, platform as a service. Build. You have your ROS code gets compiled and gets built into an image and gets deployed on the robot, and it runs. Yeah,
that's exactly right. So both Miro ML, I talked with Verdant. I run into him fairly regularly. He's a YC startup founder. He comes to some of the robotics meetups here. Both them, and then before them, Airbotics IO in Ireland tried to do this. They rather than thinking in terms of Docker or whatever, they think of it as the problem to be solved, which is deployment management for robotic software, which is a good problem to solve. It would be actually interesting to perhaps for us as a group kind of deep dive on that a little bit, because I'm kind of curious about that. And the thing that I'm curious about is why it doesn't work as a business. Airbotics failed. I don't know. I mean, I wish Verdant best of luck, but I think it's a tough one. And the reason why I think it's tough is, and that's kind of the post-mortem that I got from the Airbotics folks, is that deployment management is so critical to a company that you don't want to outsource that. That's sort of the thing in a nutshell. So it's just too risky, right? If that company happens to be gone next week, then you cannot deploy to your robots at all anymore. Then you need to overnight find a different solution. That was apparently one of the things that bit Airbotics. So I don't know whether this is a good thing to do as a company, unless it is open source, right? Like that's where Raputa, I think, had it right at the beginning, because, well, if it's open source, similar with ROS, right? Most people who use ROS as in a scale, like in a big business, like where they have thousands of robots, they use it in a very conservative way, which is basically to say, we're going to fork every package that we use and commit to maintaining it ourselves if we have to. And if we can't, then we're not going to use it, because we unfortunately cannot rely on these packages being maintained well. There are some exceptions, nav2 obviously that is standing out, is a fantastic, well-maintained, whatever. But a lot of the old ROS packages were not very well maintained. And so if you wanted to rely on this open source, you had to be willing to kind of carry the load yourself too. And I think that's an option when it's open source. It's not an option when it's
it's not. On the same line, Christian, the what we saw in the last two meetings, which is Tomoya's Q-Badge extension to Kubernetes, is exactly an open source solution for doing deployment on robots. And as a matter of fact, I was somehow surprised, because in the email that then Michael exchanged with Tomoya, he somehow said, yeah, I made the deployment works well, as you saw. It works. You can schedule distributed workloads between the cloud and then deploy anything you want on the robot as a container, so managed as a container, as a pod actually. But then he was saying, for the networking part, yes, I just wanted to show you how Cilium works and how it even supports multicast. So you can actually run DDS with the discovery in multicast. But then he was, from the email, from what I understand, Mike, the email you forwarded to me, he's even saying what I didn't want to believe, but you guys keep saying to me all the time, which is ROS just is on the robot, and then we use another protocol from the, because he definitely went into the fact of saying, you would scale things up in a different way in the cloud, which is the way you do. You do stateless things and you do them scalable, where you deploy 10 instances of the same thing and put a load balancer in front of it. But then in that case, I still have trouble putting together really distributed application, because so many ROS components are stateful. So move it, nav2, the planners, all the planners are freaking stateful. You either give them the context, or how do you plan?
I think Docker images are the way to go for deploying on the robot. You don't have to do the very dynamic Kubernetes type automatic scaling up and down and whatnot. I think that the people like MiraML and Airbotics, when they use Docker images in containers, they just use it as an artifact and a distribution mechanism, right? So at Savioke, we used to build APT, so dep packages, and that worked reasonably well, except that APT is actually not a very good package manager. The one big thing that it's missing is being able to have multiple versions of the same package in the repository, which you can make it work, but it's not really supposed to be that way. But that is something that you absolutely need in robotics, right? Because your fleet will never always be all on the same version, and you can't necessarily upgrade them all at the same time. Anyhow, there's some real shortcomings. Docker, and then on top of the the existence of images and good tagging and versioning and whatnot, obviously Docker gives you so much more, right? Like in terms of abstraction and so forth. And I think that's the right middle ground. I don't know that you need to go to the dynamic, Kubernetes with network overlays and stuff like that. And the other thing that, I mean, I don't know to what extent we've already heard that in this group, but I see that all the time, is almost every piece of the robotics software stack is under-maintained. And in just about any robotics company you will find. And the reason for that is very simple, because it's like robotics is just so broad. Like there are so many problems that you have. You cannot become a specialist in each one of them, right? We see that with video. Like I still see people who build their own video streaming solution by taking a snapshot of the camera as JPEG, putting it in a ROS message, doing a remote connection to ROS, unpacking it, putting it into whatever, Arvis or a website. It's like, come on, that's not video streaming. But it sort of works. And people don't really have the time to learn to do it right. And I think that's, with Docker and Kubernetes, the same thing. It's fairly easy to get started with Docker, right? Like you need a Docker file, you run Docker build. Wow, now I have an image, I can run it. I feel like Kubernetes is quite a step up, especially if you then don't want to use it in the context for which you will find a million documentations and tutorials, namely the cloud, but you want to do something crazy like distributing it to robots. For most companies, that's too sophisticated. They don't want to learn all of that, I think.
Yeah, I agree with you somehow. On the other hand, maybe because I come from that world, maybe because I was developing cloud applications before on Kubernetes, I do see a lot of advantages in the way those applications are developed. And somehow the fact that you have rollbacks automatically in Kubernetes, you can deploy new versions, and if they fail, you can do canary tests. You can integrate your CI/CD toolchain on your Kubernetes. So somehow it becomes so easy to develop a global scale service that stays always up, that it seemed like a no-brainer to say, why don't we do this also for robotic applications? But then in between comes the fact that roboticists think completely the other way around. Like you said, no need to deploy dynamically things on a robot. You turn it on, does its job, and you turn it off. And one image is enough.
It's interesting that you say, I think that there's a nuance that I missed, because you pointed out that it's the biggest benefit is a development setup kind of thing. That point was actually a little lost on me. So thanks for pointing that out. That makes a lot of sense. Yes. And in terms of dynamic deployments, no, I mean, I do think that robots should auto update their software, and I do think that you want to be agile and almost publish a new version every day. So you want them to be small, and that was actually one of the issues that we had with Docker images early on, that they were too big to update all the time. Like the apt packages, that was basically just a few ROS packages. That was like 30 megabytes. And then there were vendors coming to us saying like, yeah, why don't you use our cool solution that's based on images? And actually they wanted to sell us like partition images and, automatic rollback and so forth. And so we asked them, how big is your update? Oh, like a disk image, like 600 megabytes or more, sometimes 6 gigabytes. And we were like, you want us to distribute 6 gigabytes over LTE every 2 days? Every 2 days? No, we update like once a month. And we were like, no, we want to update every 2 days. We're fixing bugs quickly and so forth. So no, absolutely. I think robots should update all the time, but I don't know about the actual dynamic, like, ooh, my connection here went down, so I'm going to spin up another container. I think that goes to predictability, because the other thing about robots is there are so many moving pieces. It's so hard to keep track of what's actually going on. Like, and also when you find a bug, or you find you get notified of some sort of bug or bad behavior or some error. 2 days later, an engineer finds the time to look at that. The first 2 hours that they spend on that is trying to puzzle together what was the state of the robot when that happened. Which version did it run? Where was it? What did the cost map look like? Right? And for that, I think it's unless you have that totally, nailed down with logging or whatever, simplicity really helps a lot, right? So if there's not too much
This
dynamic
is also
stuff,
why what Foxglove is selling, right? It now the one of the big players, if you want, in cloud robotics is indeed Foxglove, because they sell you the user interfaces with the cloud service that does exactly that. You collect all your data, similar to other cloud robotics offerings that are collecting logs mostly, but makes sense.
Yep, exactly.
It seems like some of the problem you have with Docker is distributing everything in one big image. So, I mean, ROS2 as an image, I think, is like 3 gig minimum. One of the advantages of using KubeEdge that we didn't experience exactly, but we understood, was that you can deploy separate components for each thing. So a minimal deployment for publishing camera images, another minimal deployment for running the wheels, let's say, and then you only apply the parts to the robots that can understand them. So that is more of a piecemeal way of deploying.
Yeah, you could do that with Docker too, but I guess it's true. Most people that I know who run Docker on their robots, they tend to have one ginormous container with everything in it, RAWs and so forth. They don't use these microservices very much. Yeah, you could though, right? It becomes more cumbersome when you have more of these small pieces. Then the deployment becomes more cumbersome. Docker Compose works reasonably well. I mean, it's sort of, I think, a very pragmatic step in the sort of deployment, like Kubernetes direction, without having to do this distributed control kind of thing. And then in your Docker Compose, you can still have 20 different containers if you want. And then in terms of the big size, I mean, there are obviously solutions, right? And the big one is the layer cache. So if you're careful about your Docker image and you only make changes at the end, then the changes that you have to pull in after a new image is released can be very small. It requires some diligence, but can be pretty small.
Yeah, we're using very large images for our robots, also because the other thing we do is we make sure they work. And to make sure they work, you have to run all the components all together with the right versioning. And then, I mean, I think Docker as a developer tool was really solving that problem, right? Works on my machine is a thing that now you can replicate easily by shipping the image that works on your machine to the robot, and then it does.
Yeah, it's interesting that you because you still have that. This is the not the sim to real gap, but the dev to production gap, right? Which is also a well-known thing. And in robotics, again, harder than everywhere else, because when you're running on your dev machine, yeah, you might run against a simulator or some. But how do you do that? Because your runs on your machine does not actually mean that it will work on the robot once you talk to actual actuators and sensors and so forth. Do you face that problem a lot?
Yeah, we do, and I mean even more, because the images, for instance, for some of the robots are running Raspberry Pis, or they're running Jetsons. So actually, the containers we're building have a completely different architecture. So you have to rebuild them there, or cross-compile them, and whatever. And so, yeah, the sim to real gap shows you do try your software in simulation, then you build the container on the robot itself, and then you try it out, and then you find out that there's timeouts, the camera doesn't work, whatever. So
yeah,
just a lot of testing, unfortunately.
Yeah, a good friend of mine works at well at a large AV company. He was at Intrinsic before, and he talks a lot about hardware in the loop testing, which I think is really what you need for overcoming this problem, right? Where it's not just, okay, we test in dev on our machines, now let's deploy it to production. No, you definitely, usually most companies will do that manually. They have robots in their office, they will deploy to them, they will run some tests, but everybody dreams of doing sort of hardware in the loop CI/CD, where almost it's like a GitHub action that deploys to a robot, runs some tests, gathers the results, and feeds that into the test result before a PR gets merged. Often a bottleneck is simply access to test robots, because most companies struggle. Well, they don't have enough robots in the office for everyone to have their own, and then one for each pull request. And these tests also run for a long time. This is a really interesting problem to solve. I think that I think is something where yeah, I don't know whether these deployment management solutions have started tackling that, but I think it would be worthwhile.
It definitely would. And once you have hardware in the loop, we almost wrote a funding proposal for a project that had hardware in the loop. And we worked with some experts, and I didn't know that actually when you're doing hardware in the loop, you can do it at several levels. So if you're not even trusting the devices you have to somehow fiddle with the electronics to try to give us an input to the camera or to the LiDAR or to whatever it is that is supposed to, and depending, so, and then if you say, okay, the cameras or the LiDARs are certified by somebody else, so I'll work at the level of simulating that device, then it becomes already easier. You're just simulating, or you're just having smaller hardware to test instead of all the sensors.
Yeah, that's the other aspect. Like, in software testing, we would call it mocks, right? Like when you create a mock version of a database or something like that. In robotics, we have that everywhere, right? Every part of it. Well, if you want to test your high-level behavior, let's say you're using behavior trees and you want to test them, well, you better not run on a robot in an actual lab, because that takes forever. So you want to simulate it, but even simulating it in Gazebo will take too long, or it's unnecessary, right? So you abstract away. But then if you want to test your LiDAR calibration, you want to mock other things, right? And so, but mocking itself can be is a huge effort if you're talking about simulating laser, well, sensor data, especially when you need to match that up with. Imagine the situation where you want to mock your laser data, but you want to have real camera data. Well, they probably won't match, right? Because your robot will drive through a real world that keeps changing. Even if you take a recording of or some sort of certified recording of your LiDAR from before in that same environment, it will probably still not match. And so when you see errors, you don't know, is it because of the mismatch between those things, or because the code that I'm testing is actually broken? I don't even know why we torture ourselves doing robotics. I mean, it's just it's just so hard.
I'll just add that to the list of notes I've been taking. Doing robotics is torture, quote.
Well, I guess only if you want to be sure that they work. If that's only optional, then
if you want to make
this is probably roughly what we don't have a lot of AV people show up in this group, but I suspect that is part of the reason why AVs are so hard, right? Because failure is not an option. And simulating testing on streets is not always possible, and it takes forever. And so instrumentation and various levels of hardware in the loop testing is probably 90% of the problem that they need to solve, I suspect.
I had another thought. This is harking back to, I don't know, 10 minutes ago. The large Docker image downloads. One possibility that I have made an example for is that you have an edge server that downloads the Docker image, and then you can distribute that over Wi-Fi or something. Then you're not doing massive downloads over LTE or similar. I don't know if Kubernetes would understand how to do that. Someone better at Kubernetes than me would have to tell me.
I guess it depends how the kube edge is connected to the other nodes, but I guess it depends on that, and then you can configure it, I guess, but I don't know.
Yeah, I think that I don't know either, so it's at least complicated enough that Giovanni doesn't know. I took some summary notes. Don't know if you'd like to add to them. We've basically agreed that Docker seems like the way to deploy. Works on my machine, works everywhere. Large images means lots of downloading, even with caching. And it may not work if there's real hardware that's not on your machine, like if you were simulating. Would be good to have some.
I think that last point applies whether you use Docker or not, right? It puts a little wrinkle in the benefit, perhaps, but the difference of your dev machine and a robot is obviously still there even if you use a different distribution mechanism or packaging mechanism. So I think that Docker still helps a lot.
I guess that's if you're building one large image, then that's different to building smaller, like microservice type stuff. Because you can build microservice type stuff for I have a cost map, how do I navigate it? That's not going to change based on your robot hardware. So maybe I can note that.
What we use Docker for is also to isolate from the host operating system of the robot. We tend to have older robots, or the Jetsons are not so easy to update to a modern Ubuntu 24.04, for instance. So you use old operating system, and then you use the latest ROS container, which still runs unless you need to touch the kernel or install some module. Then you can. What we even did was running different versions of ROS using different containers to check out which one was working better for us on the same hardware. So that's also quite useful.
That's another place where I saw Docker be used very successfully, upgrading ROS, right? Like when you want to migrate, in that case, it was just from ROS kinetic to ROS noetic or something like that. And then the decision was to have two containers, one for the kinetic stuff, one for the noetic things. And then you could move things over like one by one, right? As opposed to having to do everything in one fell swoop, which is usually where things fail, right? If you have to line everything up perfectly so that at one point you just sort of flip the switch and it works, that approach doesn't usually work, because as you're trying to line things up, the world continues, and you now need to update two versions, the old one and the new one in order so that you can switch the old one so that your running fleet is not handicapped, whatever. And then that's actually that's a very nice use of, and that's one thing that worked really well in ROS 1. I don't know about ROS 2, but in ROS 1, the cross ROS distribution communication worked pretty well. Noetic with melodic, kinetic, no problem, right? And I don't know how that works with DDS. Something tells me that with Xeno it's not going to be a problem, but I don't know about DDS. Have you tried that?
Yeah, we have, for instance, a very old robot that actually runs the drivers for moving the wheels are still in ROS 1. And funnily enough, we found a ROS 1 to ROS 2 bridge container that uses galactic and noetic, I think, in the same container. And then we use galactic to actually talk with Humble, which is the container that is actually running nav2. And surprisingly enough, my colleague Leo even managed to get that running with Xeno. So he took the galactic container, added Xeno to it, and got it to talk to Humble and our cloud containers through the Xeno router. So nice. It still works quite well.
That sounds like a very good blog post.
It sounds like a Franken robot.
Which is what robotics is all about. I mean, it's maybe in the first year when you build your first 2-3 robots, they're all clean, all the same version and so forth. But then, time moves on and you need to start upgrading, and you cannot upgrade everything at the same time. So you have a Frankenstein almost all of the time. So you better, commit to it and realize that's what it's going to be. So let's build our tooling so we can handle these in-between states. So I think this really reflects on the reality of robotics.
I'm Christian. I saw you posted about the fleet manager on ROS Discourse, by the way. I haven't had time to try it yet. I didn't have. I'm teaching 3 days a week now, and I'm completely swamped. But so now it's moving forward also. Can you also, what I wanted to ask you is if you can launch, because I remember you're using Node.js, right? So it's very much for launching Node kind of things. But can you also launch processes or Can it?
Yeah.
Yeah.
You could. I mean, so our capabilities are NPM packages. They contain 3 sub-packages, one for the robot, one for the cloud, and then web containers, web UIs. And NPM, originally stood for the Node Package Manager. Now I think it's just NPM, one of those famous, it's not an acronym, it's just NPM, whatever it is. But it makes sense because it's actually a very good package manager, and it can contain any payload. In fact, it has its own build system. It's called GYP, GYP, that they use for compiling native code, and a lot of heavy ROS package node packages such as the RCL Node.js, the Node.js bindings for ROS2, do compile quite a bit of native code. So C, C++, Python, well, that's not compiled, but you can have that also as a payload. So yeah, you can, but yes, you can have other content, and you can even contain storage that is then built on the machine itself, if you want to. A lot of packages, again, RCL Node.js does that too, will try to fetch pre-built binaries from the cloud instead, and then they have the support for detecting the architecture. So you pull an ARM64 versus an AMD 64 image or whatever. So yeah, you could include all of that. We haven't per se experimented much with it, but you could.
Because that's what I would be mostly interested in. I mean, the functionalities that we mostly run on robots are containerized. So it's already a Docker container, and most of the time it's just launching a Docker run command or an entry point to a container that then spawns all the ROS nodes that you need. But then I would need something. I had some students working on fleet management projects in the past. Some people were using systemd, and configuring systemd, but that was one way, of course. But then their design was not nice because they were using ROS to control systemd. So somehow not. So and I saw different solutions, but something that works where you can simply turn things on and off easily would be quite useful.
I see. You're thinking almost more like a launch file, or yeah, that is more similar to sort of this deployment management topic that we haven't tackled yet. Now, one of the things of Transitive is that on the robot everything is sandboxed. So that means by design you do not have a lot of control over the robot, and that's by design because we wanted like on the Android or iOS, when you install an app, you want to be sure that app doesn't do anything bad on your machine. So in order to allow third-party packages, which we plan on having at one point, we wanted to be locked down a little bit. So you, by design, don't have necessarily the level of access that you need. That said, you could probably still launch processes, just not anything that requires sudo or any sort of elevated privileges.
That would be enough, typically. I mean, if you can launch a process, then you just configure the system so that your user is in the Docker group, and there you go. You launch your Docker group. The problem is with many, a thing we didn't discuss, that is a problem with Docker, is many times when you need access to the devices, so the cameras, the lidars, and these sort of things, you run the containers in privilege mode, or you mount as volumes the /dev directory so that you have access to that. And that was even worse, as a matter of fact, now that I think of it. I think Tomoya mentioned it, and he wrote it somewhere. That is even worse if you're using Kubernetes or the kube kind of things, because every resource that can be shared across pods needs to be declared to the system. So if you have a GPU, or if you have whatever device that can be accessed concurrently, then Kubernetes or kubelet needs to be aware of it. And that's an extra layer of complexity somehow.
Yeah, I think a lot of people run their containers in privilege mode. As like you said, especially if you need access to your cameras, you don't, for that, you don't, I don't think you need privileged mode. It's enough to mount the /run/udev, but that already gives you a lot of access. And so it's not, you don't, I think a lot of robotics companies basically give up some of the protection that comes from Docker and just use it as a, like we discussed, as a deployment mechanism and imaging solution.
On the other hand, they're not multi-user systems, so and you're just running that. So
right. Yeah, you tend to trust yourself. Maybe you shouldn't, but most people do.
I guess we could end up having third-party images that are malicious.
Yeah, that's, I mean, yeah, people do pull Docker images and to run things. I'm not sure that they do that a lot on the robot, but you could still run those without privileged mode and just run your own your own image with privileges. Definitely, if you just run a little microservice, whatever, MQTT broker on your robot, or like an RTSP server, some people do that. There you typically just do it without privileges, and those images tend to be designed like that, where they don't need that. They're also smaller, right? Like they are really like the typical Docker container microservices. Most robotics companies, again, they make these huge images with everything inside. It's sort of a different way of using it. Still fine. I'm not critical of it. It's just that it's a very different way of using it.
So I think the original topic that you brought up was essentially, what do we think of deployment mechanisms? I'm not sure the discussion we've had has presented a better option than KubeEdge, and I don't know if mainly because of my difficulty setting it up. I think there's surely other answers.
Yeah, but what Christian is saying, just Docker is enough. But then again, Christian, you need a fleet manager way for starting those Docker containers, which I see no solution out there, no open source solution that does that.
Well, there's a really cheap way of doing that, and that is, so with Docker Compose, by default, that you start your containers with always restart. So in the moment the machine reboots, all of your containers come back up. And then the only question is, how do you do the updates? That is something, yeah, I actually don't know how people do that. Some people use Ansible, of course. It's sort of one of those repeating stories. People think, oh, Ansible is great. And then they realize that Ansible is push-based, which is terrible for robots, because most of the time, some of your robots will be offline. And so running an update will only catch 90%. And then the next day you try again and you catch another 90% of the remaining 10%. And then you're at 99%, but still some robots are not there. So it turns out to be you end up chasing down a lot of robots. So eventually they realize you need something pull-based, where the robot wakes up and basically asks, what should I be running? And that's actually where I like systemd a lot, because systemd services, they can be tiny, right? And you can even run them in user, as like with the --user, so as a user service, so you don't need root or whatever. And a very cheap way of doing this deployment management is you do a systemd user service that does Docker pull latest. And the nice thing about Docker pull is, if you already got all of the layers, it doesn't do anything. And only once that is done, it runs Docker Compose up. And the nice thing about Docker Compose up is it will check whether the image has actually changed. And if it hasn't, then it will not touch the running container. So it's pretty neat. It's pretty low overhead for a first cut solution. What this doesn't give you is the assignment of which version should I be running, right? Which is another thing.
Choice. I mean, you could use a web server and set up a little web server that says
And that's what we're doing with transitive, right? That's the story.
I guess I am biased by this thing of wanting the fleet manager GUI to let me start and stop things, because we have these robots that are always connected to their docking stations, and I don't want to run ROS on them all the time. I just, also because it's a bit safer, although they're in the university, but people have access to the networks, so I don't want the ROS nodes to be up and running at all times. So I want to explicitly turn them on and off. And right now, at the moment, I have no nice fleet manager. I mean, I could build it. It's a student project. I could build this simple web UI and some message bus that just sends the signal. Okay, turn on this systemd service, which is what my students actually had done. Except that instead of using a message bus like MQTT or whatever, they use ROS itself to communicate, which was a bit too convoluted.
Yeah, then you have cyclic dependencies. Yeah, we could. I mean, that sounds like a fun project, actually. I mean, we are about to launch like a map component capability, for showing maps and like updating maps live, doing mapping and showing robots on the map and all of that jazz. But we're almost done with that. I am itching to do something simple for deployment management, especially if it's keeping it at that level of run this Docker image. That's it, right? And then either you do it automatically or there's a button or you can stop it, whatever else. That would be a fun project. Let me discuss that with my team.
Wonderful. It didn't mean to be a feature. It didn't mean to be a feature request, but
no. But I feel like you, in this conversation and through your description, we've narrowed it down so much to the very essentials, the absolute minimum, which we always want to do, right? Stand on the shoulder of giants, right? So yeah, definitely use Docker. Definitely use Docker Compose. Definitely use systemd if that's the right thing to do. And then in our case, obviously, we want to use transitive to communicate to the robot. So all of the pieces are there. I'll think about how much work it would be, but it sounds like it would be pretty small, and it would be fun to try that out together. Plus, we would finally have a joint project.
That's true.
There's another option from back in AWS. It's got a similar thing to Kubernetes, which is that you're kind of describing the target state of the system that you want. I want these components installed on it and running.
Is that
Greengrass? Yeah, exactly. And what I haven't seen anywhere, actually, is the ability to turn a node on and off remotely, just like a web UI, just like you were talking about, Giovanni. And I wonder if you can do that with the synchronized state. So you said that transitive does that. Equivalently, there's IoT shadows or whatever else a company offers, where you can ask for a node to be turned on and off. But again, that requires you to code. If this shadow is updated in this way, then I need to stop a node. So I think we have nothing out of the box at the moment.
You brought up something that is extremely interesting, because when you mention the word target and state, then immediately I teach operating systems this semester, and systemd is the next lecture, by the way. So systemd targets would be the thing to get up the system up to a consistent state. Guess what? Maybe starting some containers, maybe more than one, maybe just one. And you can easily switch the target you want to be at. But somehow I see also now, while I was thinking about it, I also see the overlap with something that they also do in ROS, which is life cycle of nodes now, right? Because that's basically exactly it. That's also making sure that the set of distributed nodes are aware of the state of each other, so that they can go to the next state, whatever. So there is a bit of overlap there, and it would be good to not redo it, or not to somehow leverage it if possible. Oh, I have it. I mean, one would have to read the life cycle state of a component and then expose it as a state of a service in systemd. Then you have, except the state of services in systemd has a bit less semantics than what you have in ROS.
So you want to, is that because systemd has this this dependency relationship where it says like, if this, start this after this has complete, okay.
After,
That's
before, requires, depends. Yeah, you have all this this relationship between components that you can enforce to make able the system comes up consistently.
Yeah, that is a repeating problem that I've heard many times before too. Like starting a robot. It sounds so simple, but yeah, making sure things happen in the right order. That's a nice idea. I never heard of that, because it is true. Like systemd is actually a wonderful technology. Like it's so sophisticated in terms of, and all of those features that it has for dependencies and timing and sandboxing too, if you want to, right? That's where we looked at it at one point.
This is also, I imagine, why I don't know why they didn't use systemd and ROS2 to do in lifecycle management, but I suspect it's because they have more complicated states for the ROS components that they have. I don't know.
And Windows, right? And Mac, right? I mean, in the moment you want to support ROS, like on Windows and Mac, you cannot lean into the systemd and Ubuntu ecosystem, unfortunately, and then you reinvent a lot. And that's a lot of the criticism, right? I mean, like one of the repeating criticisms that I hear is that why didn't you just use CMake? Why did you have to use Qualcomm and Emmet or whatever? And I think here it's similar, right? Why do you have to have your own launch system? Well, because systemd doesn't exist everywhere. That's one answer.
Can it also be that, I don't know if systemd can do this, but if something goes wrong and you need a recovery state and then start back up again, can targets repeat essentially?
Yeah,
they can fail. I've never done automatic actions, but yes, I mean you can see that the target is not reached, and then the default is if a service doesn't start properly, it's retried n times. But I don't know about automatically changing target. That I have never tried.
So you could potentially define different possible target states of the system using systemd and some ROS2 systemd integration, which I think is really neat, by the way. It's a good idea. And then you could remotely set what you want the target state of the robot to be. I want it to be online idle. And then it shuts down any nodes that try and do any work. And through your systemd definitions, it would know this is no longer needed, shut this down.
Except that systemd targets right now are not so sophisticated. You can build on top of targets, as far as I remember, but you cannot be in. So if a target includes another target, for instance, it's like run levels in Unix. You can say single user, multi-user, multi-user, networked, graphical user interface. So those targets are somehow including the other. I don't know if you can have. I don't think you can have two parallel targets like camera on and nav2 on in parallel. I don't think you can have that. For those, you just use services. So you just turn them on and off, basically.
Yeah, that's true. Yeah, I wonder if there's a way to do it with ROS2 life cycles. But yeah, I think there is a possible solution in this for someone to build. This sounds like genuinely useful. So,
I definitely think that's what nav2 is doing, basically. So if you see nav2, it's basically when you start it by default, it doesn't start many of the nodes until localization works, for instance. So if you're using AMCL, until AMCL is started, then nothing else is started. So it is using that, but it's really done for nodes that are really tightly bound to each other.
This is a good reminder too that the other issue that robotics companies have is there's more than one state, right? Like sometimes you want to bring the robots up into production mode. In the other case, you want to bring it up into mapping mode. And in mapping mode, you don't run AMCL. You run, like a SLAM solution that will provide the localization. And then you need to support both, and you're going to reuse some things like navigation. You probably want to reuse, but maybe with different parameters, and that's another one to consider.
Yeah, but that's why launch files are there, and that's why they're so complicated. Because you are somehow, for each launch file, you have a set of nodes that you're starting with a set of parameters. That's basically it. That's basically what the launch file does.
We are coming up on time, and I think... Oh, we are coming up on time. And I think last meeting we were just saying goodbye when we got cut off. So I'll say any notices now. So I wanted to mention that there's a few people I'm talking with about potentially doing talks. None of them will be very soon. I think it would be more like late April for one of them. Others I'll try and get in, but it's hard to push volunteers. There's a potential, my contact at NVIDIA has asked if I wanted to do a talk there. So I may potentially write a talk about the Cloud Robotics Working Group, what we do, what we're trying to accomplish, give it at NVIDIA. Hopefully that'll spread some awareness and maybe get some of them to come and talk to us as well.
Will you be able to record that? That would be great to post on our page. And
absolutely. Open by default. I'm recording everything. Don't you worry. Trying to think if there's any other notices. I think that just leads on to next week would be another catch up. I was going to talk about our Cuba Edge results, but I think that was already on the website. So if you wanted to see the feedback we gave to Moya, it's there. Also the email, I sent it privately to Giovanni because I expected to talk about it in the meeting. So maybe I would post that as an issue in GitHub so everyone can see it. I'm not trying to hide it. I do want everyone to be able to see it. So I'll probably do that. And I think that's about it. So next time will be a general catch up unless we have some kind of technology we want to try out.
Sounds good.
And that is time. We're probably about to get cut off. So thank you for coming, everyone, and see you next time.
Thank you. Bye.
Thank you. Have a good day.
You too.